teams do we have?
We have 7 more teams. This team and 6.
So we have 7 minutes.
Okay.
5 minutes each.
All right, we've got a 4-minute video. I assume we're going to skip that now. Okay, all right.
A 4-minute video on the website, we can watch it.
Okay. Yeah, it's at the back of this. All right. We good? Yeah. Cool. All right, hi. We are the Chicken Coop team. And I was talking to a friend of mine in the civil department, and he had a professor that was really looking to learn more about the environment her chickens are in. They have an experimental chicken coop on UC Davis land, and specifically she wanted to know things that have been done before, which are temperature, humidity, and ambient light, all sent to a Bluetooth app and recorded on an SD card. And she wanted to track the chickens in and out of the coop using RFID. And in our case, we're going to use also an IR trip to make sure RFID is reading correctly. So yes, this is the Chicken Coop product. You want to talk about the sensors?
Yeah, sure. Next one. Yeah. So for our project, we have an IR receiver and an IR LED. The IR LED, we power using a 38 kilohertz signal so that the IR receiver can detect it. And basically this is used, we have 2 of them, and they're used so that we can track the direction that the chicken is moving in so that we can tell whether or not it's moving in or out of the coop. And here we have our sensors for tracking the ambient measurables in the coop. We have a Honeywell temperature and humidity sensor, and then we also have a Vishay light sensor.
So for the RFID, we have, courtesy of Professor Niemeyer and Professor Knossen, a D-Think EM4305 RFID reader, which scans on the 125 kilohertz band. And EM4305 is industry standard for poultry and other smaller livestock. Currently, we also have a SparkFun kit that we've been using to prototype, which also uses an EM standard code, but it's EM4001. And then this is a picture of the 4305 tags. You can see the band there where they go around the legs of the chickens, and then in that little extra plastic part is the actual RFID tag itself.
So with each chicken free phones app, you can able to assess those data whenever the user has BLE in their smartphone or tablet. This is the first version of the application, and it is really simple to use it. There's only 3 steps. There's one, just press the first button to search for scan for a device, and then the second button to connect to the device, and then the third button to see the data. And now it will show temperature, humidity, and light data in broadcasting within each 9 seconds. And then this is our Finite State machine. It's really simple. There's 2. One is input. The temperature, humidity, light sensor will be input in the timer, and the output reading the temperature and the humidity and the light. And then the chicken counter, there was iron trip, and then 5-second timer, and then the output will be the chicken counter, how many chicken go in or out to the coops.
Okay. So here's our signal diagram that she's just talking about. We get our light data and temperature humidity data, which gets sent to the PSOC, which then can send data to the Android app. And then we also get our chicken trips from the IR and the RFID off the IR sensor and the RFID module. And this is the Finite State machine for our environmental monitor. It's very simple. Basically, just every 10 or 15 minutes, it'll turn on and then measure the data. And then once the data collection is complete, it will go to, and it's been recorded on the SD card. It'll go back to standby mode and go into sleep.
So this is how our IR trip works. We have 2 sensors set up in a line, and we're assuming the chickens are not the most logical creatures. And so in one case, if it breaks the first beam and then breaks the second, we know, yes, a chicken has entered. However, we've seen a couple of them walk maybe up, turn around, go back, walk in, spin twice, walk out. And so all we're trying to do here is account for that and just say, by using a timer, if it breaks the first beam but not the second, we're going to assume that if 5 seconds have passed and nothing has happened, it decided to turn around and not enter the coop.
Are you trips apart from each other?
What's that?
Yeah, 2 trips apart.
2 trips, yeah. So
Why so far?
one, because we have a little bit of an issue with IR reading, and 2, in between we have the RFID sensor, so we want to be able to see a clear pattern with a little bit of time in between trip, read tag, trip.
And you mean the first thing you have to trouble with what? You said you had a little bit trouble with the IR?
Oh, well that just, the emitter
Yep.
can sometimes spread out and touch the other receiver.
It's a 10-degree IR emitter.
You can do
We can
time-
cone that.
You can do time multiplexing.
That's true.
Right? And I would try to get them as close as possible.
Okay.
And,
Okay. Okay. Yeah. Next. So this is our communications chart. What is this?
Yeah, so our temperature and humidity sensor communicates over I²C. We measure the light sensor is basically like a BJT, so we measure the using an analog to digital converter. Our RFID module communicates with our PSOC over UART, and our IR sensor also gives an analog voltage that we read. And then our PSOC communicates with our Android app over BLE.
And then this is a power chart. First, there's like a solar panel to power the battery, which is like 12 volt, and they give out like 80 to 110 amps per hour. And then we like connect to the inverter and like a power board, which like step down to 3.3 volt and 5 volt for both boards. Yeah.
Can you go back? So they're going to, okay. Come on.
So this is our current progress. We finished breakout assembly. We have a working board that reads temperature, light, and humidity and records the values all on an SD card. We have firmware for the IR and breakouts for the IR, and coming in the mail, we have a probably second to last finalized